This is practice problem 4-6, and it's very similar to 4-5 in that we need to find the reaction forces on this truss assembly. And you can see it's loaded up. It has the dimensions as shown. It's 60 feet wide, 15 feet high, and it has forces in both the horizontal and the vertical directions. So let's begin by drawing a free body diagram of the outside of the entire truss. So I have a truss that looks like this. Make sure I draw it right. Okay. And another one of those. That. And that. Okay. I have a single force wherever there is a roller on the far right hand side. I have two forces on the left hand side where there is a pin. I will call this force B, I will call this force AY, and I will call this AX. Now, what are the actual applied forces? Over here at this corner, I have 8 kips. I have 12 kips right in the middle. And I have 10 kips here and 20 kips here. So, again, beginning with the sum of the horizontal forces. I have AX pointing to the right, plus 20K pointing to the right, plus 10K pointing to the right. So they're all positive, and those equal 0. Now there are no other horizontal forces, so I can immediately look at this and solve for AX, and that is negative 30K, or 30 kips, which means instead of facing to the right, because it's negative, AX actually faces to the left. That's all it means, equals 30 kips left. Okay, if I sum up all the vertical forces, I have an AY plus a B. They're both positive. And the two downward forces, minus 12K minus 8K equals 0. And if I do a little bit of work, I can see that AY plus B equals 20 kips. Again, 3 unknowns, only 2 equations. So at this point, I need to use a third equation, so I will sum the moments about point A. I use point A because these two forces go right through point A, and therefore they contribute no rotation. A couple things that are important to notice is that you have a 30-foot moment arm to this line of force. You have a 45-foot moment arm to this line of force. You also have a 15-foot moment arm to the line of force that goes with both of those. And of course we have a 60-foot moment arm to force B. Okay, now that we've accounted for all of the moments, let us begin. I'll start with those two horizontal forces. 15 feet that's my moment arm length, times 20k plus 10k. That's actually going to be two forces that have the same line of force. So you can just add those together. And those will cause a moment that goes to the right, or clockwise, yes, plus a 30-foot moment arm times 12 kips. Again, causing rotation in a clockwise direction, plus a 45-foot moment arm times an 8 kip. You should all say kip. Again, to the right, minus a 60-foot moment arm times force B. And as we've seen in the past, if I've gotten rid of, or I've made my AY the pivot point, then both of these forces drop out, and I can solve directly for force B. Okay. Oh boy, the moment from these two is 450 plus 30 times 12 is 360 plus 45 times 8 is another 360, and that equals 60b. All I've done, whoops, that should be equal to 0. Now I've taken that negative 60 and moved it on the other side of the equal sign. So now if I sum up these three, that's 1170. And that has units of kips times feet. And this has dimensions of feet. So 1170 over 60 equals 19.5 kips, and that equals force B. Now, AY plus B equals 20. So AY plus, I substitute my 19.5 in for B, and I end up with AY equals 0.5 kips. And there is my final answer.